Hello and welcome back. The topics that I'm going to discuss are network terminology and mesh analysis. So let us start. So here one circuit is there, one network is there which consists of three loops and the currents are I1, I2 and I3. So how to find out I1, I2 and I3? So we have to apply KVL in each and every mesh or loop. So here suppose current flowing is I1. Now if this current flowing is I1 and suppose we assume the current flowing through R2 is I2, then this will be I1 minus I2 according to the KCL, because incoming current is equal to outgoing current. Similarly at node E, incoming current is I2 and suppose current flowing through R3 is I3, so this current will be I2 minus I3. So this is the first step. We have to assign current, we have to consider the current in each and every branch. So I1 is a mesh current and I1 minus I2 is a branch current. Similarly, I2 is a mesh current and I2 minus I3 is a branch current. Now, current flowing through R4 is I1 minus I2 and that flowing through R5 is I2 minus I3 as I told you. Now, applying KVL in this loop A, B, C, D, A. So, starting with the here, current is entering in this direction and we are traveling the direction of current. So, this drop will be negative. So, minus I1 R1. Now, here similarly, we are traveling in the same direction of the current flowing through R4 is I1 minus I2. So we can write minus R4 in bracket I1 minus I2. Now here, negative terminal of the battery is coming first. So plus E1 is equal to 0. If we solve this, we are getting I1 in bracket R1 plus R4 minus I2 R4 is equal to E1. The next one, applying KVL in second loop, that is B, E, F, C, B. Now we are traveling in the same direction of the current. So minus I2 R2 will be there. Then for R5 we are traveling in the direction of I2 minus I3. So minus R5 in bracket I2 minus I3 plus, now here plus minus sign is there. So we are encountering the negative terminal first of the I1 minus I2 current. So it will be plus R4 I1 minus I2 because current is entering here, so it will be plus, it will be minus, and we are coming from this direction. So minus sign will be first, so it will be plus R4 in bracket I1 minus I2 is equal to 0. If we solve this equation, we are getting I1 R4 minus I2 in bracket R2 plus R4 plus I5 plus I3 R4 I5 is equal to 0. This is the second equation. Now, applying KVL in the third loop. So starting here, starting with the resistor R3, we are traveling in the same direction of the current, so it will be minus I3 R3. Now, we are encountering the first positive terminal of the battery, so it will be minus E2. Now here, this is plus sign, this is minus sign. So if we move in this direction, we will be encountering the minus sign first. So it will be plus R5 in bracket, that current, that is I2 minus I3 is equal to 0. If we solve this, we will be getting I2 R5 minus I3 in bracket R3 plus R5 is equal to E2. So as there are three currents, we are getting the three, as there are three loops, we are getting the three equation which consist of three unknowns. Now, unknown currents are I1, I2 and I3. Now, how to solve the equation with three unknowns? So here, suppose these are the three loop currents equation, that is I1 plus 3I2 plus 4I3 is equal to 14, I1 plus 2I2 plus I3 is equal to 7, 2I1 plus I2 plus 2I3 is equal to 2. So this equation consists of three unknowns, that is I1, I2 and I3. The number of unknown depends on the number of loops in the circuit, number of meshes in the given circuit. So first we have applied the KVL in the each and every loop, then we will be having three unknown equation. Three equation with three unknowns. Now how to find the value of the unknowns? So we can use the determinant method, Cramer's rule. So now above equation can be written in the matrix form as, now writing the coefficient of each and every unknown, that is 1, 3, 4, then here 1, 2, 1 and here 2, 1, 2. Then constant are 14, 7, 2 and unknowns are I1, I2 and I3. So this is how we can write the given equation in the form of matrix. Now, unknowns should be compulsory on the right hand side. Now, value of the common determinant can be found, that is the delta is equal to, writing the coefficient of each unknowns. So 1, 3, 4, 1, 2, 1, 2, 1, 2. So 1 in bracket 4 minus 1, then minus 1 in bracket 6 minus 4, then plus 2 in bracket 3 minus 8. And if we solve this, we'll be getting minus 9. Now, delta 1, that is a subdeterminant. So here, delta 1 is related to the I1. So coefficient of I1 is replaced by constant value. Constant are 14, 7, 2 in each in all these three equations. So all the coefficient of I1 are replaced by 14, 7, 2, and remaining two columns are as it is. If we solving this equation, we will be getting 18. Delta 2. So in this case, the column of I2, the constant of coefficient of I2 is replaced by the constant. So, and remaining first and third columns is as it is. So 1, 1, 2, 14, 7, 2, 4, 1, 2. And if we solving this delta 2, we will be getting minus 36. And the third one is a delta 3. So in this case, the coefficient of I3 is replaced by constant value. So we will be getting, and first two column will be as it is. So 1, 1, 2, 3, 2, 1 and 14, 7, 2. And if we solving this, we will be getting minus 9. So these are the delta 1, delta 2 and delta 3, and we have also determined the delta. Now, according to the Cramer's rule, current I1 can be determined using delta 1 by delta. The value of delta 1 is 18 and value of delta is minus 9. So it will be minus 2 ampere. I2 is delta 2 by delta. So minus 36 divided by minus 9. So it will be 4 ampere. And I3 is equal to delta 3 by delta, that is minus 9 minus divided by minus 9, that is 1 ampere. So this is how we can solve the given circuit using mesh analysis. First we have to identify the mesh current and branch current. Then we have to apply the KVL in each and every loop. Then after we will be having the equation. The number of unknown depends on the number of loops. And we have seen that how to solve the equation with three unknowns using Cramer's rule and determinant method. Now moving towards one example based on mesh analysis. So here one network is there which consists of three currents I1 and I2, I3, and we have to determine the mesh current. All the resistance are in ohm. So starting with the starting with the 10 ohm resistor. So suppose this is I1, so polarity will be plus minus. Now current, if this is I1, current flowing through 2 ohm resistor will be I2 and polarity will be plus minus. If this current is I1, this current is I2, then current flowing through 5 ohm resistor will be I1 minus I2 and polarity will be this. Now, here suppose current flowing is I3, so this current is I2 and this current is I3, so the current flowing in 1 ohm resistor will be I2 minus I3. If we will be adding, suppose this is I1 minus I2 and this is I2 minus I3, so this current will be I1 minus I3 according to the KCL. If we will add I1 minus I3 and I3, we will be getting I1 back. Now applying, so this is the first task. We have to assign the polarities, we have to assign the branch current and loop current. Now applying the KVL in each and every loop. So applying KVL in loop 1, so starting with here. So if we will move in this direction, we will be encountering the negative terminal first. So this will be 50 volt, then minus 10 I1, then plus sign is coming, so minus 5 and current is I1 minus I2, then minus 3 I1 minus I3 is equal to 0. If we solve this equation, we will be getting 18 I1 minus 5 I2 minus 3 I3 is equal to 50. Now applying KVL in this loop, so starting with the here, so first if we start with the 5 ohm resistor, we will be encountering negative terminal for negative sign first. So it will be 5 I1 minus I2, then minus 2 I2, then minus 10 and minus 1 I2 minus I3 is equal to 0. And if we solve this equation, it will be 5 I1 minus 8 I2 plus I3 is equal to 10. And the third one, if we apply KVL in loop 3, so starting with here, now suppose we are moving in this direction, so we will be having a negative sign first. So 1 plus 1 into I2 minus I3, then plus sign is coming first, then it is a minus 5, then here plus 3 I1 minus I3 is equal to 0. So If we solve that, we'll be getting I2 minus I3 plus 3, I1 minus I3 is equal to 5. So these are the three equations which we are getting. Now, how to find out I1, I2 and I3? So first, writing all these three equations, now finding the delta of this equation, that is a common determinant, writing the coefficient of each unknowns, 18 minus 5 minus 3, 5 minus 8, 1, 3, 1 minus 4. So value which we are getting of common determinant is 356. Now delta 1. So in this case, the coefficient of I1 is replaced by constant. So 50, 10, 5 and remaining two column is as it is. If you solve this, you will be getting 1175. Delta 2 and delta 3. In the case of delta 2, coefficient of I2 is replaced by constant. So new delta becomes 18, 5, 3, 50, 10, 5, minus 3, 1, minus 4 is equal to 355. And delta 3, in this case, coefficient of I3 is replaced by constant value. So, and remaining two column remains as it is. So 18, 5, 3, minus 5, 8, 1, 50, 10, 5 is equal to, if we solve this, we will be getting 525. Now, I1 is equal to delta 1 by delta, as we have already seen. So, putting the value of delta 1, 1175 divided by putting the value of delta common determinant, that is 356, we will be getting 3.3 ampere. I2 is equal to delta 2 by delta. So, we will be getting I2 is equal to 0.997 ampere. And I3 is equal to delta 3 by delta, putting the value of delta 3 and delta, we will be getting 1.47 ampere. So this is how we can solve the given network using mesh analysis. Again, the point to be remembered is that first identify the mesh current and branch current, assign the sign of IR drop, then applying KVL in each and every loop, then writing down the three equations, then finding the value of unknown using Cramer's rule and determinant method. So this is all about the today lecture. In this video lecture, I have discussed about one example based on Kirchhoff voltage law. That is nothing but the example of mesh analysis. Hope you have enjoyed the video. Thank you for watching.